let's discuss one of the basic problem related to plane mirror. The question is, a candle 4.85 centimeter tall is 39.2 centimeter to the left of a plane mirror. So we take a plane mirror. We take a candle something like this. The candle is 4.85 centimeter tall, is 39.2 centimeter to the left of the plane mirror. Where does the mirror form the image and what is the height of this image? The options are given as bit A 39.2 centimeter right of mirror, bit B 39.2 centimeter left of mirror, bit C 15.3 centimeter right of mirror, and bit D 15.3 centimeter left of mirror. Now, since mirror only reflects the perpendicular component, that means here one thing additional part I will like to say about it, magnification is 1. That means height of image by height of object will be equals to 1. Exactly not 1, it will be just like laterally inverted. We can say like that, -1. That means if I that means here we can say this object is at a distance of 39.2 centimeter. So image will be exactly at 39.2 centimeter. Because mirror only reflects the perpendicular component, here the magnification doesn't change. So whatever the height of the object will be, the height of the image will be same. So the option will be 39.2 centimeter right of mirror, that is nothing but bit A. So problem number 2 says, a plane mirror lies face up making an angle of 15 degree with the horizontal. So this is the mirror which is making an angle of 15 degree with the horizontal. A ray of light shines down vertically on the mirror. That means this is the ray of light. What is the angle of incidence? What will be the angle between the reflected ray and the horizontal B? The first of all, whatever the orientation of the rays may be and whatever the orientation of the mirror may be, we will always take the perpendicular component of that ray. That means I will drop a normal on the mirror. This is not about the velocities of the particle or something like that. Earlier we discussed about the velocities of the particle, where we took the perpendicular component of the velocities or component of velocities which is perpendicular to the mirror, and mirror always reflects the perpendicular component. Here it is about a simple case of reflection, laws of reflection, that is angle of incidence is equal to angle of reflection, provided we drop a normal to the mirror. Whatever the orientation of the mirror may be, always we will drop a normal on the mirror. So here if we see carefully, I dropped a normal and this is angle of incidence. So obviously this is 15 degree, this will be 15 degree, this will be also 15 degree reflection, this will be also 15 degree. Now the first question says, what is the angle of incidence? Angle of incidence or angle of reflection is the angle made with the normal. So I write angle of incidence, or whenever they ask question, angle of reflection is always angle made by the rays with the normal. Normal I write it in capital. Normal means perpendicular to the mirror. So this is 15 degree, this is 15 degree. So angle of incidence is 15 degree. Now he is saying what will be the angle made by the reflected ray and the horizontal. So I draw a horizontal. This is a horizontal line. Obviously we know this is a vertical, this is horizontal. Angle between this total is, let this angle be theta. So total angle is 90 degree. So theta plus 15 is equal to 90 degree, or theta is equal to 90 minus 30, which is nothing but equals to 60 degree. Options are given as bit A 30 degree comma 30 degree, bit B 15 degree comma 60 degree, bit C 15 degree comma 45 degree, bit D 15 degree comma 30 degree. Option will be bit B, which is nothing but 15 degree comma 60 degree. Now a balloon is moving upwards with a speed of 20 meter per second. When it is a height of 14 centimeter from the ground in front of a plane mirror, in situation as shown in the figure, a body drops himself from the balloon. Find the time duration for which he will see the image of a source S placed symmetrically before plane mirror during free fall. I draw the figure first. This is the plane mirror which is at a height of 2 meter, and this ground which is at a distance of 12 meter, and there is a point source, something here S, which is at a distance of 50 centimeter, and exactly I take in this is a balloon which is at a distance of 5 meter, and this is moving upward with a speed of 20 meter per second. Now he is saying exactly when it is over here, the boy drops himself from the balloon. He wants to see the image of the source in the plane mirror. Find the time duration for which he will see the image of the source. This is the source. Image of the source placed symmetrically. Symmetrically means this distance will be equals to this distance before plane mirror during free fall. And this is a very interesting question. If you look carefully, this is 5 meter, means instead of 5 meter, I can write here 500 centimeter. Now the boy drops himself. So let us say, whenever this kind of questions are given related to plane mirrors, take the rays from the extreme point of the plane mirror. We can say that is called view of mirror. I put one definition over here. Field view. Field view of plane mirror means, suppose this is a mirror and source is over here, anywhere, anywhere. I want to find out through which area or through which part I can see the image of the source. Take the reflection from this end. Take this reflection from this end. Now if I place an eye means human eye, I can see the image of this source through, if I place an human eye over here. That is called field view of mirror. If this mirror is placed like this and the source is somewhat placed like this, take the extreme rays, that's all. If I place an eye over here, then I can see the image of the source. This is called as field view of a plane mirror. Whatever problems are related to plane mirrors, take the reflection from the extreme end of the plane mirror. That's all, to solve problems. Now I will take now if you look carefully, I name this A, B, C, D, E, F, G, H, I, J, K, L. If you look carefully, triangle AEF is similar to triangle ABE. Triangle AEF is similar to triangle ABE. That means this one will be 1 meter. So obviously this one will be 1 meter. So obviously this one will be 1 meter. So I write like this. So I can write BE is equal to 1 meter. Triangle ABE is similar to triangle ACD. That means this triangle is similar to this triangle. By midpoint theorem you can easily prove it. This is 500 centimeter, this is 50 centimeter. So obviously this one is nothing but 10 times of this 50 centimeter. So if this is 1 meter, obviously this will be also 10 meter. 10 times. I repeat once again. Since AE length and AD length is 10 times of AE length, so obviously CD will be 10 times of BE length. So since it is 1 meter, so this one will be definitely 10 times means 10 meter. Similarly, I can write KL is also equals to 10 meter. I can write, and we don't take the geometrical specifications over here. So now if you look carefully, the boy drops himself from this point. Let us find out whether its velocity becomes 0 at point C or not. So here initially the boy drops himself with a speed of 20 meter per second, and he is climbing to a point C. The distance is 10 meters. So I can write Vc square is equal to Vd square minus 2g into h by kinematics theorem. Now Vd square will be nothing but 20 whole square 400 minus 2 into, I take g to be 10 over here, 10 into 10, so this is 200. So Vc will be 200 square root, so this is 10 root 2, root 2 I take 1.414, so 14.14. That means at point C the velocity of the boy does not become 0. So I write at point C. It's a very essential point. Some questions they might frame where the velocity at point C becomes 0. So at point C, velocity of boy does not be 0. When we drew this symmetrical triangles and all those things, that means here the boy can see the image of the source throughout this range. Through this range, the boy can see the image of this source through this range. By symmetrical things we proved. But at point C, the velocity of boy or speed of boy does not turn out to be 0. So what happens? From point C, he will go little distance up where the velocity turns out to be 0. So let us say that point to be point X. That means from C to X, the boy is not seeing the image of the source. So let us first calculate the total time for which he sees the image and he doesn't see the image. After that we can subtract for the time from the total time for which he doesn't see the image. So here I write it, total T is total time. So this becomes very easy to calculate. Total time means time of seeing plus time of not seeing the image. Time of seeing plus time of not seeing the image. Let us calculate. From point D to point C, he is moving 10 meter. Again he is moving a distance, let us say it to be x. So I can write total time is this time plus again coming down, again coming down, again coming down, again coming down. We are not interested to know about what happens when it goes below 10 meter. We are least interested. So let us calculate this. This is 10. Find out by the S is equal to ut plus half at square, you know, where S is the displacement. Let us calculate this displacement, and this displacement is the total displacement. So here I write S is the total displacement. Total displacement means the displacement for which he is seeing the image and the displacement for which he is not seeing the image. So this distance is 10, so I write it 10 plus he is going again x, he is coming down again x, minus x, he is again coming 10, minus 10, this distance will be 2 meter, minus 2, again this distance is 10 meter, minus 10. So if you calculate this x and x cancels out, 10 and 10 cancels out, so the total displacement becomes minus 12. So the total displacement for which he is seeing the image plus he is not seeing the image is minus 12. So I will put this minus 12 is equal to, from here the velocity is 20 t minus half into 10 into t square. So this becomes 5t square minus 20t minus 12 equals to 0. This becomes a quadratic equation for which we have to calculate this time t. So here we can calculate this time t as minus b 20 plus minus b square minus 4ac minus plus 4 into 5 into 12 divided by 2a 10. So minus b plus minus b square minus 4ac. So this becomes 20 plus minus 4 into 5 20, 240 plus 400 640 root over divided by 10. So minus sign will not be taken into consideration. So plus sign will be taken into consideration. We can find the total time t from this equation. Now this t includes time of seeing the image plus time of not seeing the image. Now let us calculate the time for which he is not seeing the image. Now the time for which he is not seeing the image, so I write here, let it be t dash, for which time of not seeing the image the distance from C to X and X to C. At X point velocity is becoming 0. We have already assumed it, at point X velocity is becoming 0. At point C we know the velocity at point C we have already calculated. At point C the velocity was 14.14 meter per second. So time of going from C to X time is, I can write V by G, again X to C, again V by G. So total time, let it be T dash, is nothing but 2, so Vc by G, Vc by G, Vc by G. So that is 2 into 14.14 divided by 10. So this becomes 8 to 28 divided 2.8 something 2. So here we calculate the total time T, and so according to the question, find the time duration for which he will see the image of source placed symmetrically before plane mirror during free fall will be, let it be T double dash, will be nothing but total time T calculated over here minus T dash. So whenever we use these calculations and by taking this square out, it will be approximately, and the options are given as 5 seconds, bit A 5 seconds, bit B 6.5 seconds, bit C 1.7 seconds, and bit D 3.75 seconds. Obviously, the time for which he is not seeing the image is 2.82 seconds. So obviously, this time minus this time will be approximately coming out to be 1.7 second, and the option will be bit C. So again, I repeat a little bit about this problem. First of all, whenever you want to calculate the wherever the reflections may be, take the extreme ray reflections. That means this is the source, this is the reflection, this is the reflection, This is the reflection. And let us find out by symmetrical principles, by symmetry triangles, the distance for which he is seeing the image, and we calculated all those things. And by using kinematics, we use little bit of kinematics to find out the time for which he is seeing the image. There can be multiple questions in this, like they can say find the total time of seeing the image plus time of not seeing the image. They can ask you what is the total time for which he is not seeing the image, and bit C options can be find the time for which he is seeing the image. So there can be a comprehension question related to this, where we can answer all. We got all these three answers. T is the total time we got over here. Here we got T dash is time of not seeing the image, and here we calculate T double dash is time of seeing the image, which is total time minus time of not seeing the image. This is problem number 4. The question is, a point object is moving with a speed v before an arrangement of two mirrors as shown in the figure. That means the question is, a point object is moving with a speed v before an arrangement of two mirrors as shown in the figure. This is the figure. Find the velocity of image in mirror M1 with respect to image in mirror M2. That means I need to find out the corresponding images in mirror M1 and M2, and I need to find out those relative velocities between those two images formed between mirror M1 and mirror M2. The options are given as bit A v sin theta by 2, bit B 3v sin theta, bit C v sin theta, bit D 2v sin theta. Now I have seen many students do it in a very different way, but we will go with a very simple approach. First of all, in mirror M2, obviously mirror M2, the image will be same as parallel, like this. Let it be I2, I write it. Same V. But when we go to mirror M1, always I said, whatever the orientation of the mirror B, mirror always reflects the perpendicular component. That means if I extend the velocity in this way, this is V, obviously this is theta, this will be theta. So obviously this will be V sin theta and this will be V cos theta. That means the object will have V sin theta moving to mirror M1 in this way and V cos theta in this way. Now always mirror reflects the perpendicular component. That means if I extend this mirror like this, always wherever you want to find out the ray diagrams, you can extend the mirrors as far as possible according to your convenience of solving the problems. Now this mirror M1 will reflect V sin theta and the parallel component remains the same as it is. That means this mirror M1, the image will be like this. This is I1. I want to find out the relative velocities between these two images. Now if you look carefully, it's all vectors. Now mirror mirror M1 has an image V sin theta and V cos theta in this way. So definitely in order to find out the relative velocity between these two images, let us just solve this. If this is theta, obviously this will be also theta. So this will be V cos theta. This will be V sin theta. Now what I am trying to do, I am trying to say, I am resolving the velocity of image I2 according to the images formed in mirror M1, that is I1. That means I am trying to resolve this velocity in the direction or against the direction of the velocity of image I1. So if you look carefully, relative velocity, V cos theta relative velocity will be 0 because they are in the same directions. This v sin theta and v sin theta relative velocity, so I write v relative. This v sin theta and v sin theta, they are in opposite directions. So obviously it will be 2v sin theta. So this becomes very simple to solve it. V relative becomes 2v sin theta without using any mathematical ways of solving the problem. Just I tried to resolve the velocity of image I2 in the direction of image I1, and I took the relative in this way, which makes me to know 2v sin theta, because it helps us to solve many problems related in this way. So option will be bit D, that is 2v sin theta. Now the next question is, figure shows a torch producing a straight light beam falling on a plane mirror at an angle of 60 degree. The reflected beam makes a spot. Let us first solve, draw the first figure, then.
Sir, question number.
Now the question is, figure shows a torch producing a straight line beam falling on a plane mirror at an angle of 60 degree. The reflected beam makes a spot P on the screen. This is the screen. So I now introduce the symbol of screen as like this, because when we go to wave optics, we will always use the symbol of the screen is in this way. So I write it, this is screen. This is the symbolic form of a screen. Now figure shows a torch producing a straight light beam falling on a plane mirror at an angle of 60 degree. The reflected beam makes a spot P on the screen along y axis. If at t equals to 0, the mirror starts rotating. That means this mirror starts rotating about the hinge. Hinge means this is about the hinge A, with an angular velocity omega equals to 1 degree per second clockwise. So I write omega of mirror is equal to 1 degree per second clockwise. Okay. Now he is saying find the speed of this spot on screen after time t is equal to 15 seconds. Okay. Now at 1 degree per second means after 15 seconds, definitely the mirror will rotate by 1 into 15, that is nothing but 15 degrees. So obviously this is 60, this is 60, obviously this is 30. Now he is making that the mirror rotates 1 degree per second clockwise. That means the reflected, if already we have discussed about like when the incident ray remains fixed, the mirror rotates at an angle theta in a particular sense. The reflected ray rotates by an angle 2 theta in the same sense. That means if mirror is rotating at an angle of at 15 degree, because after 15 seconds mirror will rotate by 15 degree, same clockwise given in the question. So if mirror rotates by an angle theta, the reflected ray rotates by an angle 2 theta. So here I will write reflected ray rotates by an angle 2 theta. 2 theta means 30 degree, same clockwise. So if I go for the another diagram over here, Now the reflected ray will rotate by an angle 30 degree. That means come like this. I think this will become like this. And this is the rotation. Because earlier, if you look into the diagram, earlier this angle was 30 degree. Now the reflected ray rotates by an angle 30 degree more. That means this was 30 degree. Again the reflected ray rotates by an angle 30 degree. So this angle becomes 60 degree. And I want to find out the velocity of the spot P. Now I have seen many students, they know, they say, sir, this is 3 meter. They simply use geometry things to find out this distance and they differentiate it. But one thing I will say you, from angle 30 degree to 60 degree, this angle, the angle is continuously changing. So when things are continuously changing, I have to use the concept of calculus. Calculus means let this distance be y, and we know finally it is making an angle of 60 degree. Let the reflected ray makes an angle theta with the horizontal. So I write over here, that means this is the this is 3 meter. So I say, let us say it is making an angle theta with the horizontal. So I can write y is equal to 3 tan theta. Because tan theta is equal to y by 3, y is equal to 3 tan theta. So I differentiate this. dy by dt is equal to 3 tan theta differentiation secant square theta into d theta by dt. We know finally it is making an angle of 60 degree over here, and I have to find out d theta by dt. So we know d theta by dt is that is the angular velocity of the reflected ray. So I write here d theta by dt equal to angular velocity of reflected ray. That means we know angular velocity of mirror is 1 degree per second. So obviously angular velocity of reflected ray will be 2 degree per second. So 1 degree per second means here I write 180 degree is pi radian. 1 degree will be nothing but pi by 180. So it will rotate by 2 degree. So this becomes 2 pi by 180. So here I write this dy by dt is nothing but velocity of image p. So Vp is equal to 3 secant square theta into d theta by dt is 2 pi by 80. So I can substitute the value. 3 into secant square theta is nothing but secant square 60 degree into 2 pi by 180. And according to that, options are given as pi by 30. So here I can write this is 3 into 4 into 2 pi by 180. So here we can cancel it like 3, 60, 4, 15. So this becomes 2 pi by 15. So the options are given as bit A pi by 30 meter per second, bit B 2 pi by 15 meter per second, bit C 3 pi by 20 meter per second, bit D 4 pi by 25 meter per second. So here the option will be bit B, that is nothing but we got it 2 pi by 15 meter per second. I always say you again, whenever the angles are constantly changing, don't use direct algebra method, use calculus things. Always this kind of questions come, so always don't use direct method to solve it. Always when things are continuously changing, always use calculus into consideration. That's all. Go to problem number 6, which says an insect of negligible mass is sitting on a block of mass m tied with a spring of force constant k. The block performs simple harmonic motion with amplitude a in front of a plane mirror placed as shown. Find the maximum speed of insect relative to its image. That means here there is a mirror given. And this is a block. An insect somewhere lies here. That means here the insect of negligible mass is sitting on a block of mass capital M tied with a spring of force constant K. The block performs a simple harmonic motion with amplitude A in front of the plane mirror placed as shown. Find the maximum speed of insect relative to its image. Let us go to discuss about something about a simple harmonic motion. I will not go much detail about this. We know angular frequency of spring block system is nothing but K by M root over, and V maximum in a simple harmonic motion is omega into A. That means A into K by M root over. That means here the maximum speed will be at its mean position. Obviously, I think we know all about the little bit about simple harmonic motion. So let us say somewhere here the mean position is like this. So here V maximum is in this way, either going down or either going up. It doesn't matter anything, because ultimately he is asking the question, find the maximum speed of insect relative to its image. So let us say the block is going down, crossing its mean position. At its mean position, the velocity is maximum. So I take always the last few problems I said, always whenever I can extend the mirror by dotted lines, it doesn't make any difference to it. So this is 60, this is also 60, this is 30. So here I can take, this is V max is going down. The mirror always reflects the perpendicular component. So if I take the components, the V max is like this. I can take over here, and I can say the perpendicular component will be like this. So obviously I think this will be 30 degree. Because this is 30, so this will be 30, this will be 60, again this will be 30. So this is V max cos 30. This is the perpendicular component of the object. That means the object's perpendicular component to the mirror is V max cos 30. Obviously the mirror will reflect this one. Now the question is, find the maximum speed of insect relative to its image. Now insect speed is V max cos 30 in this way, image speed is V max cos 30 in this way, because sine components will obviously cancel out, because mirror does not change the parallel component. Mirror always reflects the perpendicular component. So this is V max cos 30. So obviously this will be V max cos 30. So relative, V relative will be nothing but 2V max cos 30. Now this is 2V max cos 30 is nothing but root 3 by 2, cancels out. So this is root 3 V max, and V max already we have got it. This is root 3 A K by M root over. Options are given as A K by M root over, A root 3 by 2 K by M root over, bit C A root 3 K by M root over, bit D is 2A M by K root over. So answer will be bit C, A root 3 K by M root over. Now the question is, two plane mirrors A and B are aligned parallel to each other as shown in the figure. So this is two mirrors. Aligned parallel to each other as shown in the figure, and the distance between these two mirrors is already given, that is 0.2 meter. Length of each mirror is given as 2 root 3 meter. It's saying a light ray is incident at an angle of 30 degree at a point just inside one end of A. This is mirror A. So find the number of times the ray undergoes reflections, including the first one, before it emerges out. So this is the normal already given in the question. So obviously the reflected ray will make an angle of 30 degrees same. Let us find out how much part this ray covers over here. Let us say this is x. We know this distance. We can write tan 30 degree is x divided by this distance, 0.2 meter, and we can write x is equal to 0.2 into tan 30 degree. So we can write 0.2 into tan 30 degree is, let it be like that only, later on we will substitute. Now for number of reflections, we know the length of x part and we know the total distance of the mirror. One mirror is 2 root 3. So here I can write number of reflections is nothing but I can write 2 root 3 divided by x. So this is 2 root 3 by 0.2 tan 30. So this is 2 root 3 by 0.2 into 1 by root 3. So this is 2 root 3 into root 3 by 0.2. So this is 2 into 3 into 10 divided by 2. So this is 5. So this becomes 30. And the question is says the number of times the ray undergoes reflections including the first one. That means now 30 reflections will be there. If I include the first reflection, so including the first one reflection, total number of reflections equals to 30 plus 1, 31 reflections. So options are given as bit A 29, bit B 30, bit C 31, bit D 32. So option will be bit C, that is nothing but 31. Now this is a little bit, next question is 8. An object O is just about to strike a perfectly reflecting inclined plane of inclination 37 degree. Its velocity is 5 meter per second. Find the velocity of its image in the corresponding xy components, which I will show it right now. That means this is the mirror which is inclined at an angle of 37 degree. This is an object which is moving with a speed of 5 meter per second. I have to find out, and the options are given in terms of ij components, like bit A option is given as 3i cap plus 4j cap, bit B is 4i cap plus 3j cap, bit C is 4.8i cap plus 1.4j cap, bit D is 1.4i cap plus 4.8j cap. That means he is trying to find the velocity of the image in terms of x and y components. So it's only a calculation way. Already I have said whatever the orientation of the mirror be, whatever the direction of the velocity be, always resolve the velocities perpendicular to the mirror. I put an asterisk and write always resolve velocity perpendicular to the mirror. And mirror always reflects the perpendicular component. Now I will resolve this velocity perpendicular to the mirror. So for my sake of calculations, I take the mirror in this way, and this is 5 meter per second I take. So always I will resolve the velocity perpendicular to the mirror. This will be perpendicular. This is 37 degree. Obviously this will be 37 degree. Now this is V cos 37 or 5 cos 37. So obviously, and this will be 5 sin 37. Reflection of the, this is before reflection. After reflection, this is the mirror. After reflection, the velocity of image will be, this will be 5 cos 37. The parallel component remains the same, 5 sin 37. This is 37 already given. This will be also 37, and this will be also 37. Now I want to resolve these velocities in this x component and y component. So if I, first of all, let us resolve this 5 sin 37 along x component and y component. So this one will be 5 sin 37 into cos 37 component of this, and this one will be down, I take it 5 sin 37 into sin 37. I take the component of 5 sin 37 in this way, and the components I have written in the brackets, not to make any confusion. So this is 5 sin 37. So 5 sin 37 component along x component will be 5 sin 37 cos 37. Along y component it will be down 5 sin 37 sin 37. Let us take the component of 5 cos 37. So 5 cos 37 component will be here, 5 cos 37. The component of this will be again cos 37. I write in bracket not to make any confusion. Again I will write here 5 cos 37. In bracket I write sin 37. Now the net will be this one plus this one, this will be added, and here it will be subtracted. We know sin 37 is 3 by 5, cos 37 is 4 by 5. So I write over here Vx, I first calculate that, 5 sin 37 cos 37 plus 5 cos 37 sin 37. So I calculate it, 5 into sin 37 is 3 by 5, cos 37 is 4 by 5 plus 5 into 4 by 5 into 3 by 5. So they are the same, so I can write 2 into 5 into 3 by 5 into 4 by 5. So this 5 cancels. So this is 6 into 4 divided by 5. This is 24 divided by 5. So 5 4 ja 24.8. So x component is coming as 4.8 meter per second. Let us go with the y component. So here Vy will be written as 5 cos 37 into cos 37 minus 5 sin 37 into sin 37. So this becomes 5 into 4 by 5 into 4 by 5 minus 5 into 3 by 5 into 3 by 5. So 1 5 cancels out. So this is 16 by 5 minus 9 by 5. So this one will become as 7 by 5. So 7 by 5 means 5 1 ja 5, 25, 1.4. 20. So now the net velocity will be, if I write in vector terms, it will be 4.8 I cap plus 1.4 j cap. Options are given as bit A 3 I cap plus 4 j cap, bit B 4 I cap plus 3 j cap, bit C options are given as 4.8 I cap plus 1.4 j cap, bit D is 1.4 I cap plus 4.8 j cap, and the correct option will be bit C, which is 4.8 I cap plus 1.4 j cap. So here it is nothing but a basic mathematical taking. This can be a question in vectors also. So here we just try to resolve the velocities in the corresponding directions given. A particle is projected with a speed √2 meter per second at 45 degree with the horizontal as shown in the figure. At the very instant of projection, that means here I can say that means an elevator at rest which is at 10th floor of a building is having a plane mirror fixed to its floor. This is mirror. A particle is projected with a speed √2 meter per second at 45 degree with the horizontal. Okay. At the very instant of projection, the cable of the elevator breaks. This is the, suppose I say this is the, instead of showing this, I can make it in one cable. That will be fine. This is the cable. Now, at the very instant of projection, the cable of the elevator breaks and the elevator starts falling freely. What will be the separation between the particle and its image? 0.5 seconds after the instant of projection. Okay. Now the cable has broken. The system is like this. Falling freely. Now the cable has broken and the elevator is falling freely. Now let us calculate the relative acceleration. Here also the particle is projected, the acceleration of the particle will be g, and the elevator is falling with an acceleration g. So relative acceleration g minus g will be always, and they are in the same direction, 0. That means there is no relative acceleration. Since there is no relative acceleration, let us calculate the components, y component. So uy will be nothing but u sine 45, that is √2 into 1 by √2, that is 1 per meter per second. That means particle is moving with a constant velocity 1 meter per second. Now what will be the separation between the particle and its image? Now in 0.5 seconds, the particle will move a distance of vertical distance, move a vertical distance is 1 into 0.5, that means 0.5 meter. That means the particle has moved by 0.5 meter. So obviously the image will also move by, and so since particle is moving a distance 0.5 meter, so image will recede away from the mirror, and at 0.5 seconds the image will be at a distance 0.5 meter. Now question is, he is saying what will be the separation between the particle and its image? That means from the mirror the image is at a distance of 0.5 meter. Sorry, from the mirror the object is at a distance, the particle is at a distance of 0.5 meter, and from the mirror the image is at a distance of 0.5 meter. So the total distance will be nothing but 0.5 plus 0.5. It is nothing but I can write a distance between particle and image is 0.5 into 2, that is nothing but 1 meter. So options are given as bit A 0.5 meter, bit B 1 meter, bit C 2 meter, bit D 1.5 meter, and the correct option will be bit B, which is nothing but equals to 1 meter. It's a simple question where we took A relative is 0, component, vertical component of the particle is 1 meter per second, and in 0.5 seconds what will be the vertical distance, and image will recede away the same thing, and the total distance between the particle and the image is 1 meter given. Now the next question is, a point source of light S is placed at a distance 10 centimeter in front of the center of a mirror of width 20 centimeter, suspended vertically on a wall. An insect walks with a speed of 10 centimeter per second in front of the mirror along a line parallel to the mirror at a distance 20 centimeter from it, as shown in the figure. Find the maximum time during which the insect can see the image of the source S in the mirror. That means he is saying this is a mirror. The length of the mirror is given as 20 centimeter. There is a source S which is at a distance of 10 centimeter. So the first question, a point source of light S is placed at a distance of 10 centimeter in front of the center of a mirror. If you remember that balloon and boy problem, in that question it was written the source was placed symmetrical with respect to the mirror. Now it is saying in front of the center of the mirror. The concept is very same. This distance must be equals to this distance. An insect walks along a speed in front of a mirror. That means the insect is walking in this way at a distance of 20 centimeter from it, as shown in the figure. Find the maximum time during which the insect can see the image of the source S in the mirror. Now always as insect is walking along this line, insect is walking, let this be XY, I give you. The insect is walking along this line with a speed of, speed of insect I write it 10 centimeter per second. Now if you look carefully, I always said whatever the placement of the mirror may be or whatever the placement of the source may be, always take the extreme reflections. That means take the reflection from the extreme ends of the mirror. That means this is the mirror, I will take in this way. Now I want to calculate this length. It's very simple to calculate. All geometrical interpretations. Now if you look carefully, this is 10, I name this triangle A, B, C, X is given. Now triangle ABS is similar to triangle ACB. Obviously this is 10 centimeter. So since BS is 10 centimeter, so BC will be also 10 centimeter. So this will be 10 centimeter. OS is 10 centimeter and OD is 20 centimeter. So OD is equal to twice of OS, and triangle ABC is similar to triangle ABC is similar to triangle, let it be H, triangle AFH, and since OD means I can write AH, since AH is twice the OS or twice the AB, obviously FH will be twice this, so FH will be nothing but equals to 20 centimeter. So FH is 20, this one will again be 20, again this one will be again 20. So how much distance he is moving? 20 plus 20 plus 20, 60 centimeter. That means I can say insect will see the image at only 60 centimeter along the line XY. That means along the line XY, 60 centimeter part, he will see the image. So the distance is 60 and the speed of insect is 10 centimeter per second. So time of seeing the image will be nothing but 60 divided by 10, it is 6 seconds. Options are given as bit A is 6 seconds, bit B 3 seconds, bit C 9 seconds, bit D 10 seconds. So answer will be bit A, that is 6 seconds.